Okay, welcome to day 9, solving rational equations. What we're going to do is take these rational equations that functions that we've been working with the last day, and we're going to solve equations. Well, the one thing, no one really likes to work with fractions, so one way to work around this is to multiply every term by some sort of common denominator. We try to do the least common denominator to get rid of the denominators. So we have to pay attention because we have rational functions. That means there's a fraction bar involved. And whenever you have a fraction bar, that means the numerator technically has parentheses around it, and so does the denominator. So what we need to do is find a common denominator and multiply through by that denominator. So problem number 1 I made pretty easy. I only see one denominator, and well, there's two, but they're the same. So I'm going to multiply through by 5 by every term. The first term, the second term, and even the term on the other side of the problem. And don't forget there's parentheses around these things. And then I notice that the 5 here and the 5 here cancel, the 5 here and the 5 here cancels. I'm left over with x minus 2 plus x plus 3 is equal to 6 times 5, or 30. And that problem in red is probably much easier to do than the original problem I had given to you. 2x plus 1 is equal to 30. 2x is equal to 29. And then you could just leave it as x equals 29 over 2. You do not have to make it into a decimal. Just leave it as a fraction. Next one is a little bit more difficult, not much more, but I see two denominators. I should put parentheses around that. So my least common denominator for this problem is going to be the two denominators multiplying each other. That's always a common denominator. If one denominator is a and the other one's b, their common denominator is a times b, or in this case, 2 parentheses x minus 1. That means that I'm going to do a 2 x minus 1 one time here, and even the one on the other side. Don't forget the term on the other side. Now when I do this, the x minus 1 cancels in the first fraction, the 2 cancels out with the second fraction, and nothing cancels out here. And I get 2 times 3, which is 6, minus 5 parentheses x minus 1 equals negative 2 x minus 1. Again, that one in pink is probably easier. It's more like an algebra 1 type of problem. 6 minus 5x plus 5 equals negative 2x plus 2. I get 11 minus 5x is equal to negative 2x plus 2. I'm going to bring that over and that over. So I get negative 3x is equal to negative 9. I get x equals 3. Next problem. Again, a little bit easier. I only see one denominator there. So all I have to do is multiply through by x everywhere. Once, twice. Don't forget the other side. I get x squared plus 3 is equal to 4x because these x's cancel. This is a quadratic. There's an x squared. We always set them equal to 0, and we factor to solve. X squared minus 4x plus 3 is equal to 0. Pretty easy one to factor. X and x. Let's see, two numbers multiplied at a positive 3 would be negative 1 and negative 3 to get a negative 4 in the middle. And I just do this a little mental. I do x equals 1. I have x equals 3. These are my two solutions. I can check it. By putting the original equation, I put 1 in here. I got 1 plus 3 over 1. Does that equal 4? Absolutely. I could put 3 in here. 3 plus 3 over 3. Does that equal 4? Yes, it does. Okay, again, this one's a little bit more difficult because I have something a little bit more complicated in the denominator. So I'm going to multiply by x minus 2 once, x minus 2 twice, x minus 2 3 times. I'll pick orange. These x minus 2's cancel. And I get x parentheses x minus 2 minus 3 is equal to 0. X squared minus, wow, that's terrible. x squared minus 2x minus 3 is equal to 0. I can factor this. I get x plus 1, x minus 3, and I get two solutions of x equals -1 and x equals 3. And if I want, I could check them. But I'm not going to do that right now. That leads us to our next topic. Our next topic is the one we're going to do everything right algebraically, just like what we did before. I'm going to do exactly the same process that I did before. But I make it something called extraneous solution. That means that solution does not work in the original problem that was given to you. And this is where you have to be careful. So I'm going to group my denominators here a little bit. I'm going to factor this denominator, and the way I set up these problems, it's probably going to be whatever the other denominators are. Okay, so if I look right now at the denominators, what I have set up, I'm going to move over. Right now, from the denominators, x cannot equal 1 and x cannot equal 3, because if I put those in the denominators, that means I would divide it by 0, and that can't happen. So if I ever get a solution of 1 or 3 for this problem, I have to say it's algebraically incorrect, or what we call extraneous. So what am I going to do? I'm going to multiply every term by the common denominator, which is just this. So x minus 1, x minus 3, x minus 1, x minus 3, x minus 1, x minus 3. Okay, so here we go. This is what we have. Now some things cancel out. In the first fraction, the x minus 1's cancel out. In the second fraction, it's going to be the x minus 3's are going to cancel out. In the last fraction, they all cancel out. I'm left over with 2x, x minus 3 from the first fraction, plus x minus 1 from the second fraction is equal to 2. I'll expand it out. 2x squared minus 6x plus x minus 1 is equal to 2. Again, this is a quadratic. I set equal to 0, and I'm going to factor it. So I get 2x squared minus 5x, bring the 2 over, minus 3 is equal to 0. It's a little more difficult to factor this because of the 2x squared, but that minus 3 does not give me a lot of options. I'm going to do minus 3 here. I'm going to do plus 1 here. And when I solve, I get x equals -1/2. And I'm going to put this one in red on purpose. This is x equals 3. But we said at the very beginning that x could not be 3. So even though I did everything correct algebraically, this is an extraneous solution. And I need to mark it as extraneous. And I should, basically, I'm going to box in my correct solution. So, did everything right algebraically, got two solutions, but one of them turns out to be false. I cannot use it in the original problem. So I'm going to do the same thing over here. I'm going to group my denominators. And this one is really just x plus 2. And I notice in the beginning, from the denominators, x cannot equal, well, the first one can't be 0, and the second one can't be -2, and that's what these are. So I'm going to multiply through by all this, x minus 2, x minus 2, x minus 2, and I should do it on the other side, even though it won't matter because that's the other side is 0. I get some things to cancel out. The x's cancel out. I'm sorry, it's x plus 2. Why am I saying minus 2? It's x plus 2, plus 2, plus 2, plus 2. That's my fault. X plus 2's cancel. Everything cancels, and this is just 0. So I get, I should group this also. X minus 3, x plus 2 is from the first fraction, plus 3x is from the second fraction, plus 6 is from the third fraction because everything cancels out in the denominator. And 0 times all of that is just 0. I'm going to expand it all. I get x squared plus 2x minus 3x minus 6 plus 3x plus 6 is equal to 0. And how convenient, I get these guys that cancel out. I'm left with x squared plus 2x is equal to 0. Again, I'm going to factor it. They have an x in common. And I have two solutions. This first one is x equals 0. The second one is going to be x equals negative 2. But look at that from the beginning. Both of these are extraneous. So what do I really have? I have no solution to this problem. Not going to happen a lot, but it can happen. Okay, first thing I should do is try to factor things out a little bit. And, like I said, usually when I do this and group some things, the one denominator is just the multiplication of the other two denominators. So I'm going to multiply through by x plus 7, x plus 7, and x plus 7. But I'm going to make note from the very beginning that x cannot equal 0 or negative 7 from the denominators. First set of denominators, first fraction, everything cancels. Second one, the x plus 7's cancel. And the third one, the x's cancel. So I get 2 equals 2x plus 2x minus 2 with parentheses around it, and then x plus 7. Okay, I'm going to expand things out. And I'm going to reorganize it. I'm going to bring this 2 over. And I'm going to get 0 equals 2x squared. These cancel out. Plus 14x minus 16. I see I can take a 2 out of here. Now I can factor this. I get 0 equals 2 x plus 8 x minus 1. It was a pretty easy one to factor. I get two solutions of x equals negative 8 and x equals positive 1. And neither one is a conflict from what I had set up in the beginning of the problem. So there are two solutions to this one. Okay, this next one, I had a typo on the original, so hopefully you could see that I changed the last denominator, x squared plus 4x. And again, I'm going to, this is x plus 4, x plus 4. And again, I'm going to note at the beginning of the problem that x cannot equal 0 or negative 4. That cannot happen. So I set up with my multiplication of each fraction, and these x plus 4's cancel. Excuse me, these x's cancel, not the x plus 4's. Everything cancels here, and everything cancels here. And I get 1 times x plus 4, so I get x plus 4 plus that whole numerator, because everything cancels out in the denominator, is equal to 1. I'm going to bring this 1 over by subtracting it. We'll write it in standard form. X squared minus 6x. 4 plus 6 is 10 minus 1 is plus 9 is equal to 0. And when I factor this, I get x minus 3. And I actually get x minus 3 again. So I really only get one solution of x is equal to 3. That's not a conflict from the beginning. So this is called a double root. Same solution twice. And then finally this last problem, I'm going to set it up. This is just x minus 1. So I'm going to group this and do x minus 1, x minus 1, x minus 1. And make note that x cannot equal 0 or 1 from the beginning of the problem. And the x minus 1's cancel here, nothing cancels out here, and everything cancels out here. And I get 7x plus 5x parentheses x minus 1 equal to 7. 7x plus 5x squared minus 5x is equal to 7. I'm going to subtract the 7 over and rewrite it in standard form. 5x squared plus 2x minus 7 is equal to 0. So now I have to factor this. And, well, 5x squared is going to be a little bit more difficult. But that 7 will make my life a little easier. Not a lot of choices for 7. I'm going to go plus 7 here and minus 1 here, and that will give me my plus 2 in the middle. This solution is x is equal to negative 7 over 5. But this solution here is x equals 1, and we said in the beginning x could not equal 1, so this one is extraneous. We got to make note of that.